we're doing is we're crushing the barley. See the powder? That's all starch. Later on we'll convert the starch to barley, but we want the husks of the grain to help us filter later on. So it won't stay in this general area.
So stay kind of close to top then.
It's this guy right here at the bottom. Taking hot water, and we are mixing it with crushed malted barley, and the enzymes in the grain react at certain temperatures and convert the starches over to a fermentable sugar.
Doesn't look real appetizing, does it?
It's like oatmeal. It's delicious.
Smells good though.
So what we're doing is, on the small system, I circulate the sugar water running through the grains, so that, for one, it clarifies itself because the wort flows through the husks of the grain, and the husks of the grain grab a hold of any like hazy proteins or leftover plant matter and filter it out. So it should be running clear for us in about 2 or 3 minutes. And plus, it also keeps the enzymes moving, which converts faster for us. So, just a touch. We gotta slow the flow down, otherwise we pull the sugar too fast, or pull the water too fast, and it doesn't allow the water grab as much sugar with it. This is what we call a conical. It's our fermenter. It's called a conical because of the cone shape on the bottom. So what happens is it ferments, and then after fermentation, the yeast settles at the bottom of the cone. That way, on a big batch, I can recollect the yeast and reuse it if it's a low alcohol content beer. And then when the yeast settles out, it means the beer clarifies and then we transfer it. So we're just going to assemble it. This is a bucket of sanitizer. Same stuff I sanitize the sampler with. Like a big conical. So these clamps are called tri-clamps. It's the same kind of clamp, a sanitary clamp that they would use in like dairy or other food industries. Quick connect. And once again, sanitary. Assemble this guy. This is so I can take samples during fermentation.
So like the
Yep.
piece of wood.
Same concept. What's going to happen is the water is going to flow out, flow to the pump. It's going to hit this. The spray ball in there is going to spray everything so it evenly coats and sanitize. You recording? So, quite dark, but after you can see how much is clarified. You can almost see through it. Nice amber color. So, and then now what we're going to do is we're going to transfer it into that guy. It's called the whirlpool, so that all the work is mixed evenly. Alright, now once again, we're going to run it in nice and slow, so we don't leave any sugar behind. Pretty good. And then if we pull too fast, the work can get stuck in the grain bed. It's called stuck mash. Alright, so I put the first runnings of the sugar water to work on this guy. It's called a refractometer. So what happens is the light shines through here and reflects off the sugar crystals and tells me the concentration of sugar in the work. Just look through it. The mirror is 23, but this guy will climb, it'll probably be about 24 in about 10 minutes. Alright. So we're doing is a sprinkling hot water. Are you recording?
Yeah.
sprinkling hot water over top the grains around 170 degrees so that the hot water will rinse down and help break up and loosen up any more sugars so we don't need any sugar. Going all nice.
And this is what it looks like next. Get that nice and dark and clear.
Stayed at 23 bricks. Alright, so what we're doing, boil's done. We're transferring it via the pump over to this guy again. And what's going to happen is pump over here, and all the protein and the hot particles are going to settle in a cone in the middle at the bottom because it's going to whirlpool. What the whirlpool does is it spins faster on the outside of the kettle than it does in the center, so it works all that heavier material to the center. And this is whirl flock. So the gelatinized proteins and the hot particles at the this will make it heavy at the end of the boil, so it settles out of the beer. Alright, so we transferred the wort to both kettles so that we could boil evenly. So they're getting up to boil, and then we have a little over 5 ounces going in each kettle of East Kent Goldings. It's an English hop. They look like pellets now. They pelletize them to get rid of most of the plant matter. That way we can use less hops and they don't take up as much room in our kettle or absorb as much liquid from our wort. So let's show it boiling. Now what's happening is we're boiling it. And the reason we boil it is to sanitize it. It won't sterilize because it's not under pressure, but we sanitize it. And then it causes a chemical reaction known as hop break, where the leftover proteins in there explode and gelatinize, so it's going to want to boil over. So I have the hose ready to spray it down to break the surface tension so that it doesn't boil over. So we'll see how good of a hop break we get. What we're doing here is we're dropping the wort through the pump, through the heat exchanger, which is running cold water next to the hot wort, and we're dropping the temperature down to fermentable temperature. So I like to start at about 65. So it's going to pump all the wort into there, and then we'll put the yeast in there, and from then it'll start fermenting. And as soon as we pitch the yeast, it's considered beer. We'll probably go. We're transferring it via the pump over to this guy again. And what's going to happen is what's going to happen is we will. Sorry, I had the hiccups. Beer is going to be pumped over here, and all the protein and the hot particles are going to settle in a cone in the middle at the bottom because it's going to whirlpool. And what the whirlpool does is it spins faster on the outside of the kettle than it does in the center, so it works all that heavier material to the center. What we're doing here is We're dropping the wort through the heat exchanger, which is running cold water next to the hot wort, and we're dropping the temperature down to fermentable temperature. So I like to start at about 65. So it's going to pump all the wort into there, and then we'll put the yeast in there, and from then it'll start fermenting. And as soon as we pitch the yeast, it's considered beer. That's what we call the hop cone. It's all the hop break from the boil and the hop particles. That coagulant we threw in there grabs a hold of that, and the whirlpooling, like I said, makes it settle in a nice cone in the middle so we can pull a clean wort. So this is called the original gravity. This is what we use to, it starts off with a number, and then after fermentation we take another reading. That's called final gravity, and then there's a calculation. We figure out our alcohol content from there.